Imagine being asked to build a storage box so secure it has to outlive the pyramids, the internet, and probably humanity itself. Oh, and it's holding radioactive waste that glows with regret for 100,000 years. No pressure. Well, Sweden took one look at that challenge and said, "Hold my lingonberry juice." In early 2025, Sweden kicked off one of the most epic, under-the-radar construction projects ever, digging a tunnel half a kilometer into solid bedrock, not for treasure, but to bury nuclear leftovers. Welcome to the Forsmark Spent Fuel Repository, also known as Earth's least visited, most dangerous time capsule. While other countries are still playing radioactive hot potato with temporary storage, Sweden's going full-on ancient tomb vibes. Except instead of gold, it's glowing garbage. So how does it work? And why do scientists think it'll stay shut tighter than a jammed IKEA drawer for 100,000 years? Let's dig in carefully. The nuclear waste conundrum. Ever since nuclear power became a commercial reality in the 1950s, it's been hailed as a modern marvel. Clean, efficient, and capable of generating massive amounts of electricity with zero carbon emissions. Today, over 400 nuclear reactors power roughly 10% of the world's electricity supply. And while that sounds impressive, there's always been an elephant in the reactor. What do we do with the waste? Not all nuclear waste is created equal. Some of it low-level waste, like protective clothing, tools, and medical gear, can be handled relatively easily. It's not especially dangerous and decays to safe levels in a few hundred years. That's practically a blink of an eye in nuclear terms. Then there's intermediate-level waste, things like reactor parts and used filters, which contains more radiation and sticks around longer, but does not need cooling. These types of waste are already stored in secure facilities, sometimes underground, and don't pose enormous long-term risks. But then there's the real troublemaker, high-level nuclear waste. This stuff, which makes up only about 1% of all nuclear waste by volume, holds almost all of the radioactive punch. It includes spent nuclear fuel rods that have finished their useful life in a reactor but remain so radioactive they can be lethal for tens of thousands of years. It's the kind of material that demands more than just a sturdy container or a do not touch sign. Temporary measures with temporary confidence. Right now, the go-to method for handling spent fuel is fairly straightforward. First, the rods are stored in large water pools that act as both a radiation shield and cooling system. The water keeps them cool and prevents the buildup of dangerous heat. After a few years, once their temperature and radioactivity drop a bit, they are transferred to massive steel and concrete dry casks. These casks are then placed in secure facilities where they are monitored closely for cracks, corrosion, or any sign of a radioactive tantrum. But here's the catch. None of these methods are permanent. They require constant oversight, regular maintenance, and are vulnerable to power outages, political instability, and yes, even earthquakes. The 2011 Fukushima disaster in Japan showed what can happen when cooling systems fail and radioactive material is exposed. The result? Meltdown, explosions, and long-term environmental damage. It was a grim reminder that temporary solutions don't cut it when the waste remains dangerous for millennia. And that's what makes Sweden's Forsmark project so groundbreaking. It does not just seek to contain the waste, it aims to seal it off from humanity and the environment permanently. Deep beneath the Earth, just a stone's throw from the Forsmark nuclear power plant on Sweden's eastern coast, lies the site of the world's most ambitious radioactive time capsule. The location was not chosen at random. It's geologically stable, has low seismic activity, and the ancient bedrock beneath it has remained solid and undisturbed for almost 2 billion years. If there were ever a place to bury humanity's most toxic leftovers and be confident they won't come back to haunt us, this is it. Construction began in early 2025 with a projected cost of just over $1 billion. The facility will be more than 500 meters underground, accessible via a winding 5-kilometer ramp. But the real magic happens in a sprawling network of tunnels below, over 66 kilometers of them. These tunnels will house up to 6,000 specially designed copper canisters, each containing around 2 tons of spent nuclear fuel. And yes, the entire system is built to keep the waste locked away not for decades or centuries, but for 100,000 years. That's a level of long-term planning that makes even ancient Egyptian architects look like short-term thinkers. The KBS-3 method. The technology being used in Forsmark is called KBS-3, developed by Sweden SKB Company. It's a multi-barrier system inspired by how radioactive materials naturally exist in Earth's crust. After all, uranium and thorium have been sitting in the ground safely for millions of years. So the idea was, why not recreate those same conditions, but with a little engineering flair? First, the spent nuclear fuel is stored for 30 to 40 years at a facility called CLAB, located near one of Sweden operating nuclear plants in Oskarshamn. This period allows radiation and heat to decrease. Once it's ready, the fuel is placed into a cast iron canister, which is then enclosed in a thick copper shell about 5 centimeters thick. Copper was chosen because of its corrosion resistance, especially in low oxygen environments like deep bedrock. This copper capsule is the first layer of protection. It's then lowered into a vertical hole dug into the floor of the underground tunnel. There, it meets the second barrier, bentonite clay. This magical, absorbent clay expands when wet and forms a dense barrier that prevents water from reaching the canister. It also blocks microbes and acts as a natural cushion against any minor shifts in the rock. Finally, the third barrier is the bedrock itself. Ancient, stable, and undisturbed, it provides a fortress-like setting for the waste to rest in peace, ideally forever. As each canister is placed in the tunnel, the hole is sealed with more clay and concrete. Once all 6,000 canisters are stored, the entire tunnel system will be completely sealed, and the above-ground facility will be demolished. No signs, no monuments, no warnings. The site will be left unmarked on purpose. The theory is that the safest way to protect future generations is to make it impossible for them to even know it's there. Can it really last 100,000 years? That's the million-dollar or perhaps billion-dollar question. According to scientists, the materials and design of the repository are meant to account for worst-case scenarios, from water intrusion and climate change to natural disasters. The bedrock is expected to remain stable, and the bentonite clay acts as a self-healing barrier. But not everyone is convinced. A study by researchers at Sweden's Royal Institute of Technology raised concerns about whether the copper canisters might corrode faster than predicted. Meanwhile, environmental groups have called for more rigorous safety testing and legal reviews, which could delay progress. Still, SKB and Swedish authorities maintain confidence in the project and are pushing ahead with construction. If all goes according to plan, the first canisters will be stored in the late 2030s, and the repository will be completely filled and sealed by 2080, a global model for responsibility. Sweden is not alone in trying to find a permanent solution to the nuclear waste issue. Neighboring Finland is building its own repository using the same KBS-3 technology, known as Onkalo. It's set to open soon and marks another milestone in the responsible handling of radioactive waste. But globally, Sweden is still an exception, not the rule. In many countries, nuclear waste is stored in temporary facilities, awaiting a permanent solution that may never arrive. The Forsmark project is proof that, with the right mix of political will, scientific expertise, and long-term thinking, it is possible to solve even the most intimidating problems. Sweden's time capsule to the future. The Forsmark repository is more than just an engineering achievement. It's a moral statement, a commitment to future generations that says, "We made this mess, and we're going to clean it up permanently." It's one of the few examples of a society planning not just for the next election cycle or even the next century, but for the next age of humanity. And perhaps the most poetic part of all, the project will only be considered truly complete when it vanishes. When the site is sealed, the buildings are gone, and the ground returns to its natural state. No trace, no warning, just a silent promise buried beneath our feet. So, Should we continue using nuclear energy, knowing it comes with such long-term baggage? Or does the potential for clean, stable power justify the effort? Sweden's answer seems to be, if you're going to play with radioactive fire, at least know how to bury the ashes properly. And there you have it, Sweden's epic plan to outlast humanity with a nuclear waste tomb buried deep in bedrock. If you enjoyed this deep dive into radioactive real estate, give this video a thumbs up and hit that subscribe button. Catch you in the next video.